Let's talk about atoms and bonding. Most atoms do not exist by themselves in nature. Atoms are joined by chemical bonds. Substances containing atoms joined by chemical bonds are called compounds. So you can think of an element on the periodic table will generally bond with other atoms to make compounds. Our valence electrons determine what atoms will bond with other atoms. Remember valence electrons from our first unit on atoms and elements. Valence electrons are the electrons in the outermost shell of the atom. The number of valence electrons determines the elemental properties and which atom it will bond with. Remember, we made Lewis dot structures where we put the element symbol surrounded by dots to represent the number of valence electrons. We use the groups on the periodic table to determine how many valence electrons the element has. Atoms are more stable, or, other put, less likely to react when they have 8 valence electrons in their outermost ring. Atoms can give or take electrons to have those 8 valence electrons to become more stable. Remember, an ion is an atom that has an electrical charge, either gaining an electron or giving it away. Remember, when an atom loses an electron, it becomes positive. It's getting rid of something negative. When an atom gains an electron, it becomes more negative. So you can see we have this example of sodium and chlorine. Sodium has 1 valence electron and chlorine has 7. They can then bond together so that they now have 8 in their outermost shell. Ionic bonds can be put as polyatomic ions, which are ions made of more than one atom. Ionic bonds are the attraction between two opposite charged ions, or an attraction between a positive and a negative ion. It tends to bond between metal and a nonmetal. And ionic compounds are compounds made by ionic bonds. Ionic crystal have an orderly three-dimensional pattern formation are formed by ionic bonding. These bonds are brittle, have high melting points, and conduct electricity, when the space allows the ions to move. Name by the positive ion first, and then the name of the negative ion. So for example, sodium chloride is an example for salt. Covalent bonds is where neither atom gives away an electron, they share. So think of that saying, sharing is caring. That's covalent bonds. They tend to bond between nonmetals. It forms a molecule, where a neutral group of atoms joined by covalent bonds. So you can see these two atoms of fluorine are sharing electrons. Okay, and this item here of water has 2 hydrogen and oxygen sharing their electrons. That's a covalent bond. Ionic bonds, they're giving one away. Covalent, they're sharing the electrons to make 8 in their outermost shell. Sometimes atoms share 2 to 3 electrons at the same time. You can get a double bond where they're sharing 2 pairs of an electron, or even a triple bond when they share 3 pairs of electrons. We can get something called a molecular compound, which have low melting points and boiling points, and they do not conduct electricity well. Sometimes atoms do not share equally. If we get a polar bond, that happens when covalent bonds share an electron with a slight electrical charge. So water makes a bent Mickey Mouse shape in its structure. And nonpolar bonds, our electrons are shared equally. So carbon dioxide would be another example. It would look more like a straight line in how they're sharing those electrons. Chemical compounds and formulas happen so that we can show the combination of symbols. A chemical formula is the combination of symbols that show the atom and how much of each element is in each compound. There are some rules to counting the atoms. First, look at a subscript. Remember, that's the number that comes down slightly at the bottom of a number. A subscript after an element indicates the number of atoms of that element. If there is no subscript, then there is only one of that element. A subscript followed by parentheses represents the number of radicals in that compound. A prefix in front of the compound indicates the number of molecules of that compound. So you can see we have some examples here. We have 3 atoms represented by the red and the gray. Its element would be two different elements. The red would be one element, the gray would be another. It forms one molecule and one compound. Here's some more chemically bonded. We have 3 atoms here, only one element. These are all the same element bonded together, which makes one molecule. We would have 0 compounds here because we need to have different elements to be considered a compound. And here we would have just 2 atoms and 2 different elements. It would not be considered a molecule or a compound because these are not touching. So these are examples to help you get through how atoms bond with other atoms.